Okay guys, this is the second part of our tutorial. We're doing question 2. We're given that a catchment with an area of 3.4 kilometers squared is situated in the built-up area of Johannesburg. Built-up area means that it's an urban catchment yeah, um, calculation, and it's an inland region. Johannesburg has a mean annual precipitation of 700 millimeters. The catchment comprises of 84 hectares of grass parkland with heavy soil and an average slope of 7.8%, a 21 hectare of light industrial development, 36 hectare of downtown business area, 24 hectare of neighborhood business area, and the remainder is single family residential housing. And then they say we should allow 10% of the total area for asphalt surface street. So they say that the first 800 meter of the longest drainage path flows over land through the medium grass parkland where the slope is 6.3%. And then we are told that it then follows in a natural drainage watercourse with an average slope of 3.2% for a further 1.1 kilometer. And then the last 760 meter of the watercourse is a concrete lined canal with a slope of 22.1%. Then we're told to calculate the peak discharge from the catchment area for the return periods of 5, 10, 20, 50, and 100 years using the rational method, and we should plot the graph of our results at the end. So what you have to do, you just have to write whatever you're given. We know that the area is 3.4 kilometer squared. We know that our region, it's an inland. We know the return period that we have to calculate. We know that our MAP, mean annual precipitation, is 700 millimeter per annum. So what you're going to do, you have to determine your C. So what you have to do, you have to determine, you go to the table, it's written urban C2. So you determine the C for grass parkland, light industrial, downtown business, neighborhood business, asphalt street, and then the residential area, and then after you sum them up to get your C. Remember, now we're no longer using the same table since this one is an urban catchment. So the first land use, from the question we're given that it's a heavy soil. The statement reads like this: it's an 84 hectare of grass parkland with a heavy soil and an average slope of 7.8%. But on the memorandum, say used Lawns sandy soil. So this is what she selected. Sorry about the flash. So this is the value that she selected, but if I was writing, I was gonna go with this one since it's a heavy soil, and then we're given that the slope is 7.8%, so it has to fall here. I was gonna sum these two and then I divide by 2, but they use this way. So I'll just continue with whatever I'm given on the memorandum. You can consult with him. So what you're going to do for land use, you're given that they used 0.15 to 0.2. What you're going to do, you take the area that you're given 84 hectares. 84 hectares the same as 0.84 kilometers. You're going to say 0.84, you divide by the total area, which is 3.4. You multiply by the factor that you got. It's going to be 0.2 plus 0.15. You divide by 2, you get 0.175. 0.175, and then you see for land use is 0.0432. Next thing, you go to light industrial. What is the area for light industrial? We're given that 1 hectares of light industrial development. So it's 0.21 divided by 3.4. You look for a factor. They say it's light. So under industry, you look for light industry. So it's going to be 0.5 plus 0.8. You divide by 2. You have 0.65. And then your C for light industrial is 0.0401. And then you go to downtown business. Then you go read whatever you are given. You're given that it's 36 hectares, so it's going to be 0.36. You divide by 3.4. It's downtown business area. You go look for a factor for downtown. So you go to your table. You're gonna use under businesses, you select the first one, which is city center. So you're gonna have 0.7 plus 0.95. You divide by 2, you'll have 0.825, and then you get 0.0874. Please be careful when you read. Just make sure you understand what they're saying exactly, because sometimes they might not give you the exact words that are there on the table. Like this one is downtown business, so you know that you have to know that downtown business the same as city center. So now you go to neighborhood business. You were given that the area was 24 hectares, so it's going to be 0.25, and then you divide by 3.4, and then down neighborhood is 0.5 plus 0.7. You divide by 2, you get 0.6, and then you'll have your C for neighborhood business to be 0.0424. And then now you are told that you should allow 10% of the total area to be asphalt street. So asphalt streets, so 10% of the 3.4 is 0.34, and then you divide by 3.4, and then you go for asphalt street. We have 0.7 to 0.95. You add the 2, and then you divide them by 2. You'll have 0.825, and then you'll have your C as 0.0825. And then they said we should allow the remaining 10% to be single family residential. So you add all the areas that you get. You're gonna add 0.84, 0.21, 0.36, 0.24, 0.34, and then whatever it's remaining should be for single family residential area. So will be given by 1.41. That's the remainder, divided by, and then single family you have 0.4. So this 0.4, you go under residential areas, and then the first part is single family, so that's what you select. It's going to be 0.3 plus 0.5, and then you divide by 2, you have 0.4. So your answer here will be 0.1659. Then you see, you sum everything, you're going to end up with 0.4615. So that's what you see. And then the second step now is to calculate TC, which is time of concentration. So now here we have a different thing. We have 3 segments which are different. The first segment is an overland. So the formula for an overland is different from the one of watercourse. So TC for overland is given by 0.604 multiplied by R times L divided by S to the power 0.5 then all to the power 0.467. So your L for the first part, it was 800. You were told that the first 800 meter is an overland. So you're going to have 0.8 kilometers. And then your S, you were told that the slope is 6.3% from the question. And then what you have to read is your R. Your R values are given on the roughness condition table. So you are given that it's a medium grassed surface. So you're gonna use 0.84. So it's 0.604 multiplied by your R is 0.4, your L is 0.8 divided by your slope is 0.063 to the power 0.5, all to the power 0.467. And then you get your time of concentration for the overland segment to be 0.68 hours. Then now you go to segment 2. Segment 2 is water course. T for water course is the same one that we're using for the rural catchment. So it's going to be 0.87 times your L squared divided by 1000 times your slope, all to the power 0.385. So now you calculate for your segment 2, your TC will be given by 0.87 multiplied by 1.1 squared, that's your L, divided by 1000 multiplied by 0.032, that's your slope, and then all to the power 0.385. Then you have your time of concentration for the segment 2 to be 0.27 hours. You go to your last segment, segment 3. So you have 0.87. You still use the same formula because it's also in a water course. 0.87 times 0.76, which is your L. Then divided by 1000 times your slope, which was 2.1. Then all to the power 0.385. And then you'll have your TC as 0.24 hours. And then now you're gonna calculate your total travel time. You sum all the concentration is gonna be 0.68 plus 0.27 plus 0.24, and then your total travel time will be 1.18 hours. After doing this, what you have to do, you go to your graphs. Now you have to read. I'll show you how they read these ones. It's the same thing that we do. You go for your total travel time, you got 1.18. So you come here, 1.18 has to be between 1.1 and 1.2. So it's here. And then you draw a line. It's an inland region. You stop there. You draw a horizontal line to your return periods graph. They said it's 5 up until 100. So you draw a line there, and then your mean annual precipitation was 700. You look for 700. That's a blue line there. I'm not sure. Yeah, I think you guys can see there. Where this line touches your 500 return period, you draw a vertical line coming down up until it touches your 700 line, and then you read there, and then you do for the other ones. After reading your values, you're gonna get all your depth of precipitation for 5, 10, 20, 50, and 100 return period. After that, you calculate your after that, what you do, you're going to calculate your rainfall intensity for each return period. for 5 year you have 35.6, 10, 44.1, and then you just plug in the formula, and then after that you calculate your peak discharge. After calculating your discharge, you just produce a graph. That's what they wanted. Thank you guys for your time. I'm sorry the videos were messed up. I'm at home, I didn't have anyone to help me take a video, so that's why it's like this. And sorry for uploading the videos late. The other tutorial I will ask to help you with it. I never covered it on my transportation. I have no idea what's going on, but I will try looking into it, and then if I understand something, I'll make a video for you guys. Thank you.